Good morning, students. Now we will do the one important topic, that is the regulation of breathing. Regulation of breathing. So at the end of the lecture, you will able to tell the chemical regulation of the breathing, how the chemical regulation of the breathing occurs, what is the mechanism. Then at the end of the lecture, you will able to tell the role of chemoreceptors, that is your central chemoreceptors, what is the role of peripheral chemoreceptors. At the end of the lecture, you will be able to tell what is the role of hypoxia. At the end of the lecture, you will be able to tell what is the role of PO2, role of PCO2 on the respiratory centers, and what is the role of pH on the respiratory centers. So we'll begin our lecture. Mechanism involves the inhibition of the potassium channels. It involves the inhibition of the potassium channels. Effect of changes in PaCO2. What are the changes in the PaCO2? At lower level of alveolar PCO2, that is 37 millimeter of the mercury. 37 millimeter of the mercury. No stimulation of ventilation occurs. No stimulation of the ventilation occurs by hypoxia until the alveolar PO2 is less than 60 millimeter of mercury. So this is very important point, children. This you have to remember. And below this, the response curve is steep and linear with progressive decrease in the PO2. At high level of alveolar PCO2, an inverse relationship is observed. An inverse relationship is observed between ventilation and alveolar PO2, in which decrease in PO2 proportionately increases ventilatory response. It will increase proportionately the ventilatory response, and increase in PO2 linearly decreases ventilatory response. Okay, so a lower level of alveolar PCO2, 37 millimeter mercury.